moving into section 3 here, we have a little bit more to cover on the Windows file system. So covering some differences between FAT32, extended FAT, and NTFS, the new technology file system. We have some images here to make this slide at least a little bit more digestible. FAT32, introduced in 1996 as an upgrade to the older FAT16 file system. So we went from FAT16 to FAT32. If we think about, floppy drives as we would save our media or how we would store our file system, this is what we were using way back in the 90s. The amount of data that can be stored on it is significantly less to how much storage you can now put on even a USB or your passport external media. It's just crazy. This would hold 4 gigs. So maybe you'd be able to hold, one movie, I don't know, a Word document that has 10,000 words is probably a couple of kilobytes. So maybe you can hold like 10 large essays, I don't know, 4 kilobytes. And it doesn't support any built-in file compression or encryption. Security wasn't even a thought. It was more about functionality. It had a nice, simple, and lightweight structure, making it ideal for use of small devices like USBs and flash drives. Then FAT32 evolved into extended FAT. It was introduced in 2006, and it supported larger partition sizes for the file system, and volumes up to 128 petabytes, which is crazy. That's after terabytes, you move up to petabytes. It was designed specifically for use in flash drives and other removable storage devices. And again, as technology advances, it's just an upgraded version of FAT16 to FAT32 to extended FAT. The most important one to be familiar with and to know by name is NTFS. This is the new technology file system. This is what you're using on your Windows 10, Windows 11, pretty much any operating system. Windows 2000 plus is going to be leveraging the NTFS. Introduced in 1993, it is the default file system for Windows new technology. Supports file and partition sizes, greater volumes, offers built-in support for file compression, encryption, permissions, probably a buzzword, better security, more modern approach to a Windows file system structure, and it's just more reliable, more consistent, and it's what we're using right now is the NTFS file system. So your legacy Windows operating system devices may not be using NTFS. They may be using FAT, or if you have external media, it may be using extended FAT. These are just probably the top 3 different file systems that Windows can operate on to store all of your data. With NTFS, the new technology file system, being what you're using on your laptop, workstation, local computer right now. Moving into the NTFS, since it's the most relevant one to talk about, there's so much that you can learn about the Windows file system. It really is a beast. It's very clunky. It has so many different moving parts compared to a Linux-based operating system where everything's a file. So if we kind of break down this chart here for the master file table, the MFT being the heart of the Windows file system, kind of really hard to find a nice diagram that works for beginners just being introduced to the Windows file system. But some of these concepts we have talked about. So I thought this image from malwarereteach.com, file system for beginners. This was the most basic one that I could find. So basically, this is your new technology file system, your NTFS partition. This is the entire disk that's going to store all of your data for your files on the computer, starting at the left with the master boot record. Remember, this is what gives the system information about the partitions, and it's going to start the sector and the size. This is your master boot record. You have some reserve space. The VBR, that's your volume boot record, and it's primary boot code will load in here. The Windows bootloader was going to load in here. It's going to get executed. And this is kind of like your first sector of the partition for the drive, this being at sector 0. Computers start counting at 0, not 1. Then you have your $boot. This is the boot area that contains the Windows boot loader. $MFT, the master file table, which is what we're talking about here. So right now, we're only going to be talking about this part of the NTFS. And the MFT, the master file table, it tells the system where to find files within the system. There's a lot of different components within the MFT. The two that I want you to be aware of are std info and file name. Even then, it's probably too much information even for the introduction to the file system. And then the rest of this is where you store all of your files and data, and then another section here for some reserved space. That is the NTFS. Moving from left to right for the sectors that you have, every NTFS is going to have the MFT, and it really is the heart of the NTFS system. A lot of forensic artifacts, we comb through the MFT looking for information, and it's really a crucial component of the system used by Windows operating systems. It's going to store information about each file, every single file, every directory on an NTS volume. It's going to have file name, creation date, modification date, security, permissions, who touched it, who moved it, what time did it move, when did somebody update it, when did the bytes change. Everything will be in the master file table. When a file is created or modified, the MFT record for that file is updated to reflect the changes. So the master file table is really keeping track of any changes to your NTFS system for any updates, changes, or modifications to it. Built into this, we have these two components that break down for std info and file name. std info is going to be stored the standard file information about a file or directory, like file size, creation time, modification time. Has other metadata. Metadata is data about data, so additional information about the file, its attributes, security permissions. And then file name, that's going to be stores the file name, the extension for a file or a directory. It's going to also have metadata contained in it, and its short name and the index number of its parent directory. So what are we taking away from this slide? The NTFS partition is what we're using for any modern Windows operating system, from sector 0 to the rest of the sectors reserved on the entire disk drive for the operating system. Kind of always going to have a spot for your master boot record, your bootloader, and then your MFT, your master file table, is always going to be a value contained and allocated on the disk within your NTFS system, and have the master tracking list for anything happening to your files and directories within your operating system. Something to cover before we dive into those two categories of the MFT that I'm calling out is MacB timestamps. I would definitely be aware of what MacB timestamps are and what they stand for. So M stands for modified time. We're talking about files here, and when you have a file, it can have different timestamps associated to it. For now, these are really only the 4 file timestamps that I need you to be aware of, and which are, modified, accessed, changed, and created time. But since we don't want to do 2 C's because that would be confusing, the created time is going to be B for birth date. That's when the file was born. Every file on the Windows operating system is going to have a MacB timestamp associated to it, and whether or not that timestamp has updated or not will be tracked in the MFT, your master file table. M is the modified time. This is the time when the file's content was last modified or changed. So if I open a file, that's not going to update the modified time. If I go into my document, my Word document, and I change a sentence in there and I save it, that will change the modified time. Access time. This is the time when the file was last accessed or opened. Note that in recent versions of Windows, the timestamp is no longer updated by default for performance reasons. So always pay attention to what operating system of Windows you're using to make sure your access time information that you're pulling is accurate. But basically, if I were to open this file, the access time would be updated to reflect that latest time that I opened it or someone else opened it. Changed, again, something changed within the file. And then birth date, the created time. This is the time when the file was created for the first time, and I want you to think born. This is when it was created for the first time. It's his birth date of the file, and that should be the oldest date within all of the 4 timestamps, because these events can't occur unless the file was born in the first place. So something to be aware of. Now that we have our MacB timestamps covered, we can go back to the MFT, 2 sections that we called out, 1 being std info and 2 being file name. And this is a sans reference for MacB timestamps as they are reflected for what happens for what's changing in the MFT under std info and in file name. You don't need to memorize anything on the slide. I'm just trying to give you this information so that it's easier for you to remember and think about MacB timestamps and what can happen when files move around. Okay, so how the heck do we read this chart? So it's going to be in MABC order here. So this line at the top is your modified. This line here is going to be your access time. This is going to be your birth date, when the file was born. And we can put born here. And C for changed. Same for down here. There are different timestamps that will update based on what section of the MFT you're in. We don't need to go in depth to cover all of this, but as a basic example, if we just think about the std info part of the MFT, if I'm going to make a file, the birth date or born time is going to change. So the cells and values that are in white mean that the timestamp is going to be changed, whereas the values in black mean that it's not going to change, and the old timestamp for whatever value it was is not going to be updated. So if we take this example and we say, I made a file, I created a file, all of my MacB timestamps are going to be the same exact because the file was born. Let's say we made it at noon. I also modified it because I created the file. So that changed the file as well. And I accessed it because I had to make the file. So all of the timestamps are going to update. Now, let's say I'm done with it. I've saved it off and I want to make a copy of it. When I go to make a copy, I find the correct top line to read, and I say, okay, the file was copied. That means the access time will change for when I accessed it, as I had to touch the file. The birth date will also update as it's being born into a new location within the NTFS if I'm copying it over. And the change date will also update, but the modified date will not update because I didn't modify the contents and change any bytes within the file. Now, what if I had created the file and I had renamed the file? Well, I follow this chart. I go over to where the file had been renamed, and the only MacB timestamp that would have updated is the change. It's not going to be a new timestamp for the birth date because I created it over here. I didn't create a new file. I didn't access it. I didn't modify any changes. I just made a change to renaming the file, and the metadata will be changed for the C value for our MacB timestamps. So you can see why Windows is a beast of an operating system. No one expects you to memorize this chart or be aware of when your MacB timestamps open. What you really want to take away from this is that when you open up File Explorer and you have your listing of files and you can view in detail at the top the timestamps up there, be aware that there are 4 timestamps for a file on a Windows operating system. That's the modified, accessed, created, and changed, and you're good to go. This is just additional information for kind of getting your head wrapped around the NTFS file system, all of the crazy components that are within it, diving very slightly into the master file table and what it's tracking for file movements, copying, creation, deletion, etc. for files. So it's a very robust file system that the Windows operating system offers you.